Welcome to On Our Watch, a podcast about coastal erosion and sustainability in Louisiana. My name is Marian Evans. I'm a filmmaker and a producer of the documentary On Our Watch, a feature-length film that examines Louisiana's coastal land loss crisis and the ways in which it impacts our communities, industries, and culture. The film's director, Jonathan Evans, and I are proud to produce this podcast series that will continue to explore issues facing the Louisiana coast through conversations with local residents, community leaders, and experts. In this episode, we're speaking with Dr. Alex Kolker. Alex is an associate professor at the Louisiana Universities Marine Consortium, as well as an oceanographer, geologist, and climate scientist. And now, our interview with Dr. Alex Kolker. Well, thank you so much for joining us today, Alex.
Thank you for coming down to Kolker Tree.
Of course. So I wanted to start by asking you about what initially drew you to want to study coastal and marine sciences, and what are your particular areas of interest within that field?
Yeah, I always wanted to do some kind of the environmental sciences, but I didn't really plan to go into coastal. I went to grad school for one thing, and I realized that was maybe not the right track, and I was actually looking. I was in graduate school at Stony Brook in New York, and which is on Long Island, and I was sort of looking for different projects and ran into some people that were running a project to look at climate change impacts to New York City, and they needed someone who was an ecologist to help out with their study of Jamaica Bay, which is a wetland around New York. And I raised my hand and I said that sounded interesting. And I was originally in an ecology program, and that led me to transfer into the marine sciences programs. I realized that I needed to understand sea level rise, and how it impacts coastal systems. I realized that I needed to understand coastal geology. And somewhere in the middle of all that mix, I decided that I really liked this and that this was a really interesting, cool thing to do. Because on one level, there's some really interesting, neat science. There's, a lot of very interesting hydrodynamics, some interesting ways that water and mud moves about the coastal zone. You get very, very beautiful features. It's great field work because you're often in really beautiful areas. And it's also sort of societally interesting because almost half the world's population lives somewhere near the coast. So I didn't actually plan to go into the coastal sciences, but somewhere in the middle of my falling into them, I decided that they were a pretty interesting thing to do and that I would stick with doing that.
Yeah, great. So we're here today at LUMCON, which is the Louisiana Universities Marine Consortium.
Correct. It's a mouthful of a name, I know.
I think I got that right. So can you tell us a little bit about what LUMCON is and what your role is here?
Yeah, so LUMCON, we are the Louisiana Universities Marine Consortium. So we kind of have a couple main features. One big thing that we do is we're a marine laboratory. We are basically the research marine laboratory for the universities in Louisiana. Many big state schools have a marine laboratory associated with them. University of North Carolina does, University of Maryland does, many of the University of California schools do. In Louisiana, we're a little different in that we don't have one marine lab that's associated with one university. We have a marine lab that's associated with all the universities. So it's a little organizationally different, but it functions similarly to many marine labs. And then we also play a role in trying to coordinate marine research and education across the state of Louisiana. So that is another part of our mission. So we study the coast, we teach people about the coast, and we try to coordinate people that study the coast.
Great. And what do you primarily do here?
So I am basically the staff geologist. I am the geologist here. And so sometimes when people think about geology, they think about earthquakes and volcanoes and mountains and things like that. And Louisiana, being a geologist, is a little different. We, instead of studying big, huge, solid rock formations, we study mud or sand or sediment and how it moves about the coast. So we study, as a geologist, we study water and mud and its movement across the coastal zone, or other geologists, sedimentary geologists like me, study water and mud moving in other places on Earth's surface. And so I'm interested in the geology, hydrology, and oceanography of the coastal zone, with a focus on this place on the Gulf Coast, but it's certainly not the only place I work. And so here in Louisiana, I've looked at a number of things related to Earth's surface problems here in the coastal zone. So I've looked at sea level rise and how it impacts coastal systems. I've looked at how water and mud move in like sort of river-dominated wetlands, which is A, just a really interesting topic, and B, has some implications for coastal restoration and the kind of diversions that are parts of the state's master plan and coastal strategy. I've looked at how groundwater moves in the delta. I've more recently looked at some of our greenhouse gas emissions and where do they come in from in Louisiana, and their actual relationship, industrial greenhouse gases, and their relationship to the Mississippi River. So I've looked at a lot of this sort of coastal system from a variety of angles, often dealing with water, mud, or air, and the people that they impact.
Right. Why do you think it's important to educate people about coastal sciences, especially here in Louisiana?
Yeah, well, I think anywhere, because almost half of Earth's population lives by the coast, right? And so many people are near the coast, and as climate changes, as Earth's surface changes, as we deal with more extreme weather, as we deal with larger populations by the coast, a lot of people have risks and vulnerabilities that are driven in part by being close to the coast. So one of the most important reasons to study the coast is safety. And to think people need to understand the coast so they understand, for example, what their flood risks are. And people need to understand, how close they are to water, and not just how close they are to the water, but how high above the water they are. One of the many things that was problematic in Katrina, for example, was that people didn't necessarily know their elevation above or below sea level, and so they didn't know their flood risk, and many things went wrong in Katrina, and that was just one of the things that went wrong. But if you look at, around the world, a lot of people live by the coast. New York is a coastal city. Tokyo has several million people below sea level. Athens in Greece is a coastal city. Alexandria in Egypt is a coastal city. Casablanca in Morocco is a coastal city. So there are coastal cities all across the world, and Louisiana is a particularly interesting one because it is, New Orleans and many parts of the state are, we're near the mouth of the country's largest river. We have one of the largest complexes of wetlands. We have one of the largest commercial shipping pathways. We have some of the largest industry near the coast. So we have a long history of people living by the coast. So there are many reasons to study the coast. But in Louisiana, many of these coastal issues are some of the biggest issues of their kind in the country, and in some cases of their kind in the world.
Right. It's not just this abstract thing. It's practical reasons.
It's it's practical. It's cool and interesting and neat to look at, coastal hydrology and coastal sediments, but it also, the geology determines in part your elevation above sea level, and that determines your flood risk. The structure and currents in the Mississippi River determine or impact shipping along the Mississippi River, and that's one of the country's most important commercial shipping pathways. It's also an area, a lot of that commercial shipping feeds or takes material from refineries and petrochemical facilities that contribute to greenhouse gas emissions and also air pollution. So understanding the coast has a very practical impact on where is safe to live and where might be risky to live.
Yeah, exactly. And so, as you mentioned, one of the topics you've studied closely is sea level rise, both locally and around the world. What have you observed from studying these global trends about how sea level rise is impacting us?
Yeah, so sea levels are increasing, and here in Louisiana, they're increasing faster than in many places around the world. Sea level rise is going up globally because the planet is warming up, and ice that had been trapped in, Greenland or Antarctica or mountain glaciers is beginning to melt, and that's sending additional water into the world's oceans. So the world's ocean levels are going up as our planet warms and ice melts. Here in Louisiana, that problem is compounded by the fact that we're sinking, and so because we're sinking, water levels, at least in a relative fashion, are going up even faster. In fact, most of the water level change that we experience in South Louisiana is due to the sinking of the land. The sinking of the land, it's something that geologists argue about, but it's probably about a centimeter a year, which is a little less than a half an inch a year, whereas the global sea level rise is probably just about 3 or 4 millimeters a year. So maybe a tenth or maybe a little over a tenth of an inch a year. But of course that could change as the planet continues to warm. And the rate of global sea level rise could overtake the rate of subsidence-driven sea level rise. Being here in Kolker, I have certainly noticed that is a potentially very serious issue because, we get water in this parking lot all the time. It's not uncommon. We probably have 50, 75 times a year where we have some level of, high tide flooding in the parking lot, and probably a dozen or 24 times a year when you couldn't bring a car close to the building. And that makes it difficult for us to get to work, but it also teaches me, but I think it should teach others as well, that it doesn't take all that much sea level rise to make life difficult for a person, right? It doesn't take more than, an inch or so of water on the road to shut it down. Right? And so the risks that places face from sea level rise is significant. It's significant for us here, and I want to, part of what I'm trying to do here is communicate that this is a risk that so many other people around the world are either facing now or could face in the near future.
Mm-hmm. Right, because as you said, even if your house is lifted up, you have to drive.
You have to drive your car here. So, you can't drive a car through more than, an inch of water. Right, you can't drive, if you have an inch or two of water, you can drive slowly.
Mm-hmm.
If you have more than an inch of water, you can't drive fast. So it doesn't take that much water to shut down a road.
Yeah.
And it's sort of an interesting thing here. So because I told you our parking lot floods, we have some level of water in it 50, 75 times a year. Well, that, we weren't really built for that. It's interesting. This building, it's about 18 feet off the ground. We've got storm shutters. It was basically designed pretty well to deal with hurricanes. It was designed with the idea that every 5 or so years you'd have a hurricane, you'd put up the shutters, tighten everything down, leave, go away for a week or so as the hurricane came through, come back, clean out underneath the building, and everything would be fine and you'd be back up to normal in not too long a period of time. And it's designed pretty well for that. But it is not designed well for sea level rise. It doesn't take too much water to, make parking complicated. It, raises some safety issues because people have to walk through mud and water. And so it doesn't take too much high tide flooding to make this a really challenging place to work. We have to get deliveries here, both of, packages and scientific equipment. And so it doesn't take more than a few inches of water to make life challenging here.
Yeah. So I know that you recently served as a Fulbright scholar in Morocco, where you got to study the coastal systems there. What was that experience like, and what did you learn from it?
It was a fantastic experience. It was the Fulbright was really a great opportunity to go to another country and learn about, what people are doing intellectually, scientifically, culturally in another country. And I was, being a coastal scholar, was particularly interested in what coastal scholars and coastal scientists were doing in Morocco. Morocco has several thousand miles of coastline, and it actually has a good community of coastal scholars and coastal scientists. So I had the opportunity to work with several faculty members, one who was a coastal geologist, another who was like a coastal law and policy scholar. I got to work with their students. I got to teach classes, work in sort of large seminars, work in symposiums on ocean sciences. So it was really a fantastic experience. I had to learn some French and some Arabic along the way, which was actually un grand plaisir. It was great. It was a lot of fun. I really liked it. And so, yeah, it was really interesting to see how people in other countries are dealing with similar issues. The kinds of students that I worked there, while maybe their native language was either Arabic or French, they were very much the kind of students that I would work with here. People who were smart and interested and curious in the coast. People who collected samples, made maps, wrote scientific papers about it, analyzed samples. So in some ways it was very different, and in some ways it was actually quite similar to see. Yeah, scientists and scholars, asking similar questions and doing similar things, even though it was a very, very different setting.
Right. Yeah, that's so interesting. Is there anything that you're currently focused on right now that's particularly exciting to you, within your research or your teachings?
Right now I've got a couple big projects. One in the coastal space, I'm working on this area, Neptune Pass. Neptune Pass is the largest new offshoot of the Mississippi River. We've probably all heard that the river doesn't move through its wetlands to the extent that it used to because there's levees along the edges of it, along the edges of the rivers that prevent that kind of overbank flooding. Restarting that process is one big part of the state's coastal restoration plans. And in the last couple of years, there has been a new opening in the Mississippi River, a small canal basically widened by something like a factor of 10 or maybe even a factor of 100 over the last just couple of years. And so my team, a guy who runs a small geoscience consulting company, Delta Geomarine, a woman, Christy Swan, who runs a small drone surveying company, Arcos. We've been, along with the National Wildlife Federation and some help from Louisiana CPRA, we've been studying Neptune Pass and its geology and hydrology. And that is fascinating because it is one of the largest new deltas in the country. And so that has been just fascinating to watch. We don't really have a lot of good examples of large deltas growing in the time span where we can notice them. Because the next largest new delta to form was the Wax Lake Delta, and that formed, in the early 1970s and was built on a cut that was created in the early 1940s. So that was, long before people only started noticing it after sort of land started to build. So this is one of the first really good chances that we as a scientific community have to study a new large delta in action. So that's been one of the one really rewarding thing that I've been working on. We've also, as I said, been looking at projects about where our greenhouse gases come from and their relationship to air pollution. And so we have been basically taking a big data approach to construct maps of Louisiana and Mississippi and try and compile data on where our emissions of carbon dioxide and methane, the big greenhouse gases, as well as air pollutants like sulfur dioxide and some potentially cancer-causing volatile organic carbons, where they all come from. And actually, it's interesting, a lot of them come from places near the water. They come from either along the Mississippi River corridor between roughly Baton Rouge and New Orleans. That's where a lot of the big refineries and petrochemical facilities are. And of course, they're connected to the river because they either receive or or produce products that get shipped around on boats and barges, or some of our other big, industrial places are by Lake Charles or over in Cameron Parish again. And there's a connection to water there because again, they either are supplied by or supply boats that carry heavy materials that move about on the water. So that's been another big project. Of course, I've still got work going on in Morocco. I'm going off to talk next week to the American Geophysical Union's conference about, there was an El Nino-like phenomenon in the Atlantic Ocean this year, and that was kind of an outgrowth of my Fulbright experience. So I'll be talking talking about that at the American Geophysical Union conference. So those are, as well as some other sea level work in Morocco with some students and scholars, and those are just a few of the projects that I'm excited about now.
Very cool. So you have your hands in a lot of different things.
It's good. One thing I like about being a researcher is you have the opportunity to do a lot of different things.
Yeah.
And so I've tried to take advantage of that as much as I can. Very
nice. So what do you think are some of the biggest lessons you've learned in your scientific career so far?
One lesson is just the simple lesson that I told you, that it doesn't take much water to slow or shut down a system, right? And climate change, and as well as in combination with a lot of the other changes that have taken place along the coast, is a serious risk for coastal places, and not just in Louisiana, but across the world. We're often 10 to 30 years in front of the rest of the world. And so the kinds of problems that we experience here in Cocodrie and other places in South Louisiana are, whether it's flooding, insurance, other climate risks, these are the kinds of places that coastal areas around the world could be facing in the next 20, 30 years. So that is the first biggest lesson I've learned, is look to Louisiana if you want to look to the future. Now, another lesson I've learned is if you want to look to the future, is it's helpful to plan. And there has been a large coastal planning effort here, the Coastal Master Plan. And there have been some other people that have also brought planning ideas to the table. And I think that is another thing that I've learned, is that there is a lot that people can do working together, sharing ideas about this coast or other coasts. So another lesson I've learned is just the importance of and the practicality and the ability to, develop a plan and implement a plan. When I started here I moved here in 2007, and I started here at LUMCON in 2008. When I started here, people were just beginning to talk about coastal plans, and actually, like, one of the other main big problems in Katrina that people noticed was the state didn't, prior to Katrina, have a good coastal plan, and people started implementing coastal plans in the years after Katrina. And now the CPRA is spending $1 billion a year or so on the coast, and a lot of that is based in science and engineering and data. And so I think it does show, working together, working with science, working with scientists, engineers, the private and public sector, that you can accomplish a lot. And I think that is sort of an important lesson for thinking about science and what we can do moving forward. We face very serious climate risks, but as human beings, we're thoughtful, intelligent, capable creatures, and there is a lot we can do as a species to address our climate risks. And I think that, thinking about what Louisiana did in terms of coastal planning is one example of the kinds of things that we as a global community could do in terms of global climate planning.
Well, thank you so much for talking to me today, Alex. I really appreciate it.
Thank you so much for coming down. It was just a pleasure to speak with you.
Oh, thank you. Thank you for listening to On Our Watch. We hope you enjoyed our discussion with Dr. Alex Kolker. Don't forget to subscribe to On Our Watch on your favorite podcast app to be notified about future episodes. You can also watch a video version of this podcast on YouTube, which you can find a link to in the description. Thank you for tuning in, and we'll be back with another episode next week. This podcast is made possible through grant funds from the Greater New Orleans Foundation and executive produced by Bruno UK Steiner.